Alrighty, friends. Ooh, we got some more proof things on this one. So exciting. Let's figure this out. We can do it. Doesn't matter which side I start with. I could do it from both sides. It does not matter. I'm seeing this distributing thing, so I'm just going to distribute that. So that's tangent squared times cosine squared. So tangent squared is sine squared over cosine squared. So I'm going to think of this as sine squared over cosine squared. So that's going to become sine squared over cosine squared times, I'll just write it down, sine squared over cosine squared times cosine squared minus, I'm going to just write that as tangent squared because I see that I want that, plus cosine squared minus 1. Okay, so now I see that's going to be sine squared plus cosine squared minus 1 minus tangent squared. That's the number 1. So 1 minus 1 is 0, so negative tangent squared, and I'm done. I guess I'll do the right side here, because I feel like this wants me to multiply by 1 plus sine y and 1 plus sine y. Why am I writing squared? Don't write squared. Bad brain, bad. Sine y. So that means the bottom becomes 1 minus sine squared. I know that's sine squared plus cosine squared. Those should be the same letter. Equals 1. So that means 1 minus sine squared is cosine squared. So the denominator here is cosine squared times and then cosine on top. That should still be the same letter. 1 plus sine. Okay, I'm having some problems here with the squaredy things. Stop writing squared when they're not squared. I have cosine over cosine, so one of these goes away. Then I can think of this as 1 over cosine plus sine over cosine, which is secant, plus, ooh, I did it. Let's see what we got down here. Ooh, I see the left side is scary here, so I'm going to go for it. I see sines and cosines on the right, so I'm going to change everything to sines and cosines. I'm going to see what happens. Cotangent is cosine over sine. Tangent is sine over cosine. Cosecant is 1 over sine. And secant is 1 over cosine. All right, so I got sines and cosines all over the place on the denominator. What I'm going to do is I'm going to multiply this by sine cosine, and I'm going to multiply this by sine cosine. So I'm going to distribute that in. When I distribute the sine cosine into here, the sine and the sine will cancel out. So that will give me cosine cubed. But I don't want to write it that way. I'm just going to write it cosine squared times cosine, because I don't know if that's helpful. We'll find out. And then same idea on the next one. That's going to be sine, sine, sine. So that's going to be sine squared times sine. I don't know where I'm going, so I'm going to just write it like that. When I distribute on the bottom, the sines are going to reduce, so that's cosine minus sine. So that, okay, so I know how to do it, but do you know how to do it? Yeah, sure, you can do this. Okay. Do you know how to do that? Can we try it that way? Can I try something? I'm going to try something. It's going to be fun. I don't know if it's going to work, so I'm going to go down here. The top is cosine cubed minus sine cubed, and I'm dividing by cosine minus sine. Let's do long division. So cosine cubed minus sine cubed divided by cosine minus sine. So if I put a cosine squared, that's going to be cosine cubed, minus sine x cosine squared. Subtract down, that's sine x cosine squared minus sine cubed. So if then I say, all right, I want that first thing, so that's sine times cosine cosine. So plus sine x cosine x. Distribute that, that's sine x cosine squared x. And then minus sine squared cosine x. So my order is messed up, but that's okay. Subtract down, those pieces go away. You wind up with sine squared cosine x minus sine cubed. And then if I multiply by sine squared, hey look, it worked out. How sweet. Distribute that, and that's going to be sine squared cosine x minus sine cubed x. Subtract down, and I get 0. So I use like a polynomial long division thing. So when I divide that out, I get that big thing. But check it out. So let me group some things. You, and yep, group all that. So that means I now have cosine squared plus sine cosine plus sine squared. But those make 1, so that's 1 plus sine x cosine x, which I think is what we were starting with. Yeah. All right, we got there. So that was a tricky one. You could factor it using difference of cubes also, but you don't know that, so I went with doing some division, which you know how to do, but we've probably never done in class. We will not do that too on the quiz, but it's a good little algebraic exploration. I guess I'll just start on the right side here. I got tangent, I got sines and cosines on the left, so I'm going to go sines and cosines. So I got sine x over cosine x over 1 minus sine squared over cosine squared. Let's multiply top and bottom by cosine squared. Cosine squared. So on top, that's going to be sine x cosine x. And on the bottom, that's going to be cosine squared minus sine squared. Wait, I did it. Woo! That's like magic. Prove each identity. Okay. So sine x cosine y plus sine y cosine x. Okay, this was a terrible idea. I need more space. And then I'm going to have the same thing, but with a minus in between. So that's like a difference of squares thing. So let's see what we got. So sine x, come on, sine x cosine y plus sine y cosine x, sorry, cosine y, no, cosine x, get there eventually, there we go, forgot my letters, and then sine x cosine y minus sine y cosine x. Distribute that out, and that's going to be sine squared x cosine squared y. Middle part goes away, so minus sine squared y cosine squared x. So this tells me I want to get to there. So I got to get rid of my cosines. So cosine y is 1 minus sine squared. And cosine x is 1 minus sine squared. Distributing gives me sine squared minus sine squared sine squared. Just got to make your letters correct. Minus sine squared plus, sine squared sine squared. That and that will cancel out, so that's sine squared minus sine squared. I did it. Alright, so tangent sum. So that's going to be the tangent of pi over 4 plus the tangent of x over 1 minus the tangent of pi over 4 tangent of x. We know the tangent of pi over 4 is 1, so that's the same thing as saying 1 plus, I'm going to go to sines and cosines, sine over cosine. And that's 1 minus tangent of pi over 4 still is 1, sine over cosine. I don't like these cosines on the denominator, so I'm going to multiply by cosine and by cosine. Let us go ahead and distribute. So that's going to be the cosine plus, the cosines will go away, so sine, over the cosine. The cosines will go away, minus the sine. Is that where we wanted to get to? Please. Yes, we did it. Next one. Sine 2x and cosine 2x. So sine 2x, everybody knows, is 2 sine x cosine x. Cosine 2x, don't I have like several choices? I don't know which one to use. We could have cosine squared minus sine squared. Will that work? Yeah. Sure. I don't know if this is how you guys will do it, but it's a way. I think I'm going to write this as cosine squared minus sine squared. I feel like you're not going to think about it this way, though. So how are you going to think about it? We're off to see the wizard. I want that to be the tangent. Yes. I think this is a better way. I had one path tonight, but I think that one's a less obvious path to you. So to turn that top piece, that top right piece, into the tangent, I'm going to divide by 2 cosine, right? So I'm going to write, instead of cosine squared minus sine squared, I'm going to write it as 1 plus 2 cosine squared. 1 plus 2 cosine squared, because there are 3 different versions of the cosine of 2x. Okay, so the reason I'm doing that is because I want this to become tangent. So I'm just going to divide it by 2 cosine x to force it to do that. Obviously, if I do that there, I got to do that here. And I also have to do that here. Hey. I don't have enough room. There we go. 2 cosine x and 2 cosine x. So I divided everyone. And I think that's, okay, I think I'm going to get there. That's going to give me 1 over 2 cosine x minus, so those are going to cancel. Ooh, I need an extra cosine, don't I? So do this just cosine squared. So I'm going to have that minus, that's just the tangent. And then over 1 over 2 cosine squared plus 1. Now I need that tangent. And wait, I just realized this has to be a negative because it's not 1 plus 2 cosine squared, it's 2 cosine squared minus 1. Yeah, sorry. So that's a minus, and that's a minus. But I need a tangent. Let's see. What do I want? What do I want? What do I want? See, I had a plan, and then I changed it to try to make it easier in your brain. And now it's not the plan I wanted to do. But I'm going to get there. So I'm going to say, I've got that. All right, I don't know. Let's find. Okay. So 1 minus tangent, 1 plus tangent. Okay, that's where I want to get to. We will get there. Do not fear. I wrote all that stuff down. 1 minus 2 sine x cosine x. Okay? And then cosine 2x, which I wrote as 2 cosine squared minus 1. Okay? And then I divided everyone by 2 cosine squared. And that became, those cancel out, that's tangent. That's that. That's that. And that's 1. So I'm like kind of starting to get somewheres. I need... I need this to be tangent. So let's multiply. As I said, I don't see a path yet, but I'm going to get there. I need that to be tangent. So I'm going to put a tangent there. That's going to make the top funky, but that's okay. So that's going to be tangent over 2 cosine squared minus tangent squared over negative tangent over 2 cosine squared plus the tangent. Okay. Where do I want to get to? I forget. 1 minus tangent, 1 plus tangent. So, sine over cosine. I don't think this is getting me there. I give up. I'm going to delete all that stuff, and I'm going to try again. I don't like this path I went on. I like my path, so I'm going to try again. So let me show you the path I was going to take. I tried to think of a way that might make more sense in your brain, but I think I just confused myself, and it didn't work, and I don't like it, so I'm going to try again. So the sine of 2x is 1 minus 2 sine x cosine x. And then that's sine squared minus cosine squared. And what my brain wanted to do was rewrite the top as, that's 1, so that's sine squared plus cosine squared minus 2 sine x cosine x. And then over sine x minus cosine x, sine x plus cosine x. And the top, if I look at that, I can factor that into sine x minus cosine x times sine x minus cosine x. Because if I multiply that out, that gives me sine squared minus 2 sine cosines, and then plus cosine squared. So over sine x minus cosine x and then sine x plus cosine x. Those go away, reduce to 1. And then I want tangent, right? What do I want? 1 minus tangent, 1 plus tangent. So if I divide everyone by cosine, sine over cosine is tangent. Cosine over cosine is 1. Sine over cosine is tangent. Cosine over cosine is 1. So that's tangent minus 1, 1 plus tangent. And of course, my signs aren't working because I'm a bonehead. Gosh, this one threw me for a loop. That's supposed to be cosine squared minus sine squared, which I had before, and I wrote it wrong. All that's going to change is this sign. And that's going to make a negative show up here, which is going to fix this, which is going to be 1 minus tangent x over 1 plus tangent x. Sorry about that. Made a mistake. And I got interrupted, but I'm going to move over here now. I think I explained everything there. If I didn't, apologies. All right. What do we got? Sine 3x over sine x. I guess I will look at that as the sine of 2x plus x over the sine of x minus the cosine of 2x plus x over cosine x. So I'm going to be using the sum difference identities for both sine and cosine. I guess just the sum identities. So the sine, we're going to have sine 2x cosine x plus cosine 2x sine x over sine x, and then minus the cosine sum, cosine 2x cosine x minus sine 2x sine x over cosine x. Okay. I guess I'm going to... So I see a sign here, and I have a sign here. So I would like to have a sign up here. Same idea, I see a cosine, I'd like to have a cosine over here, because then I can get rid of denominators, and my fractions are easier. So I'm going to rewrite this as the 2 sine x cosine x plus cosine 2x sine x over sine x. You can do the same thing over here, cosine 2x cosine x minus 2 sine x cosine x sine x all over cosine x. And now I'm going to reduce out my sine on the first one, so get rid of that sine, and that sine. It's like factoring it out on top and then reducing it away. Cosine, cosine, and cosine. So that's going to give me... I forgot something. Hold on. There should be an extra cosine here, right? Right there. So that's going to give me 2 cosine squared x, I like that, plus cosine 2x, minus cosine 2x, ooh, I like that, and that's a minus, so that's a plus, 2 sine squared x. Those will go away. I can take a 2 out, and I got cosine squared plus sine squared. That's just 1, so that makes that 2, so I did it. Yippee!